Hello my dear friends. In this video we are going to find the minimum value of c by solving these two exponential equations. We have 2 to the a plus 4 to the b equals 2 to the c. And the second exponential equation is 4 to the a plus 2 to the b equals 4 to the c. Right, let's go ahead and have a look at this problem. There are two equations for three variables, so we can't get the unique solution. So how to find the minimum value of c? Well, let's do the substitution first, because there are exponential forms, and the substitution will help a lot. We can set x equal to 2 to the a, y equal to 2 to the b, and z equal to 2 to the c. Right. When we do the substitution, we will substitute x, y, and z in the exponential equations. So we will have x plus y squared equals z, and x squared plus y equals z squared. Now there are still two equations for three variables, but we can solve for x and x squared from these two equations. From the first equation, we have x equals z minus y squared, and x squared from the second equation is gonna be z squared minus y. So now we have x and x squared, and we can have another x squared by square x again. Then from here, x squared equals z minus y squared squared. Let me write it down as z squared minus 2xy squared plus y to the 4. Great! X squared equals x squared, so these two equations are equivalent. So z squared minus y equals z squared minus 2zy squared plus y to the 4. Nice! And we can solve for z from this equation. So z squared can be cancelled. If it's not easy to figure out z, we can try to move this term to the left and this term to the right. So z equals, the denominator is 2 times y squared, and the numerator is gonna be y to the 4th plus y. So finally, y squared over 2 plus 1 over 2 times y. Okay, that's the solution of z in terms of y. For now, we have a little bit progress. But you may confused how to find the minimum value of c with z. So don't worry with that. Just now we set z equals 2 to the c. So c equals log base 2 of z. So if we have the minimum value of z, then we will have the minimum value of c. Let me write it down. C minimum equals log base 2 of z minimum. So the problem here is how to find the minimum value of z. Let's look at the expression of z here. It has a sum of two terms, and what we want to do is to find the minimum value of z, which means this expression is greater than or equal to some constant. So what constant should it be? Well, an idea hits me. We can try to use the AM GM inequality for this problem. What the AM GM inequality says is that the arithmetic mean is greater than or equal to the geometric mean. In this case, we can write it as P plus Q plus R over 3 is greater than or equal to cubic root of the product of P, Q, and R. And notice that if P equals Q and Q equals R, the AM will be equal to GM. So now what we're gonna do is to find P, Q, and R for this problem. In other words, we have to make sure that the product of P, Q, and R is a constant. So what should we do now? Let me write z here. Y squared over 2 plus 1 over 2y. Some of you may guess the answer. We can set P equals y squared over 2. Q equals 1 over 4y. and r equals 1 over 4y. So the product of p, q, and r is gonna be y squared over 2 times 1 over 4y times 1 over 4y. This is gonna be 1 over 32. So here we can simply say that z is greater than or equal to 3 times cubic root of 1 over 32, where p equals q equals r. So the minimum value of z is 3 times cubic root of 1 over 32. That is y squared over 2 equals 1 over 4y. Solve this equation, we can get y. So y equals cubic root of 1/2. So the minimum value of c equals log base 2 of z minimum, which equals log base 2 of 3 times cubic root of 1 over 32. And this expression you can simplify it to get a nicer form. If you can try to simplify it, leave your comment to share with other people. So here is the answer. If you like this video, don't forget to share, like, and comment. See you next time. Peace out.